Severe weather for the central plains, but also we have continued flash flooding for the west, southwest, and also midwest and central plains. Good morning, I'm meteorologist Pew. Today is September 19, 2025. So starting with severe weather, we have a marginal risk R1 out of 5 stretching from Nebraska to Kansas. And what this entails is we only have a 2% chance to see an isolated tornado and a 5% chance to see both damaging winds and large hail. And in terms of flash flooding, we have a slight risk in central California, but a marginal risk throughout the Great Basin, southwest, central plains, and also the upper Midwest. So the time frames of when this is all going to occur, starting with the severe weather in the central plains, things are going to start pretty late today, around 8 p.m. Central Time. And if storms do develop, they will travel southeastward and travel through the night and into next morning. And for the upper Midwest, including the Dakotas, you guys have already been seeing rain and showers from remnants of last night's storms and the day before. And unfortunately, that's going to continue and very slowly travel eastward. I do want to mention in places like southern Iowa and Illinois, you guys are going to see rain probably around midnight tonight, and that's going to last throughout the night and into late next morning. And a similar thing could be said for central California, as you guys have already been seeing showers from this morning and afternoon, and this is going to continue on until this evening, and it's going to dissipate once it gets closer to the night. But for places like the Great Basin and the Southwest, you guys are going to see isolated storms around 2 p.m. Mountain Time. Okay, so now back inland and looking at 500 millibars of midway through the troposphere. For the past few days, we've had this independent low that's been traveling from Canada and intersecting with this low pressure that's in the plains right now, and that has successfully merged. Now with this merger, it did disrupt the wind flow a little bit. So for example, the shear that was in the upper Midwest and in the Midwest have kind of slowly dissipated a little bit, so we're only going to see a minimal amount. And since we have a minimal amount of shear and minimal amount of tilting those updrafts and prolonging those storms, that's why we're going to see a lot of more clusters that we're going to form in the upper Midwest and Midwest. But on the flip side of this merger, if we look at the central plains, we do have a speed max, or an area where there's going to be a lot of shear. And we also have a vorticity max headed to this area, so this area is going to have a positive vorticity advection, meaning it's going to spin those updrafts and help with the upward motion. But there is one issue with the central plains though, is that it's a little bit too warm, a little bit above the surface, around the 850 millibars to 750 millibar area. So for example, looking at this theoretical sounding this evening in the central plains, following this red line, which is the environmental temperature, we can see when it goes a little bit above the surface that it's actually causing a temperature inversion, meaning that the temperature is increasing as it goes up in height. And this dashed white line is a theoretical rising air parcel. And if you notice, the red line is going beyond to the right of that white dashed line, and that area is we call a SIN, or a convective inhibition. In other words, a cap. Because rising air parcels do not want the environmental temperature to be warmer than itself, because if it's warmer, then it's not going to rise. So to counteract with that, if we look at the surface, we do have a low pressure that is developing in Colorado, and that's going to deepen the isobars, or pressure gradient. And when you increase the pressure gradient, that's going to increase the wind speed, and so we're going to have more southerly winds, bringing in that warm, moist air into the plains. And in addition to that, if we look at satellite imagery, we can see in the south, it's pretty clear skies, so it's going to have a lot of direct sunlight, more diurnal heating, and more surface heating. And so with that being said, in the central plains, it might be warm enough and create more instability and buoyancy to break that cap and form those thunderstorms. And that's why we have